Good night, all. We're back with another video electricity and magnetism, and we now have to look at circuits. CIRCYTS. Now, circuits. A circuit rather is defined as a complete path through which current flows. And a circuit is made up of a series of different components. You have, for example, load components. Load components are anything that make use of these use current. You have your source components. These produce or generate current. You have your control components, for example, switches. They do what their name says. And then you have transmission, your conductors. These carry current. Now, these are primarily, these are what we call conductors. Conductors, D-U-T-O-R-S. Now, these usually have fairly to very low resistance. They have an abundance of charge carriers. Now, why charge carriers? Because we're talking about current flow, and electric current is the flow of charge. The opposite to conductors is insulators, and these are the opposite. They have fairly high, fairly to very high resistance, and have few charge carriers. Examples of insulators are paper, wood, rubber, plastic, even air is an insulator. Examples of conductors are almost all metals, water. I think graphite is a good conductor of electricity. But anyways, they just have a lot of free charge carriers available for the transmission of electric current. Now, circuits are classified based on the arrangement of the load components. We have two types of circuits primarily. We have series and we have parallel. Series circuits have their components arranged one after the other. Parallel circuits have their components arranged across each other's ends. Now, in a series circuit, current is constant. In a parallel circuit, current is not constant. In a parallel circuit, current is the sum of what we call branch currents. In a series circuit, voltage in the circuit, the total voltage is the sum of the individual voltages. In a parallel circuit, voltage is constant. In a series circuit, total resistance is the sum of the individual resistances. In a parallel circuit, it's a bit more fancy. So R1 plus R2 and so on. Always remember, that V is equal to I times R applies not only to the circuit but to the individual components as well, which means over here for series circuits, Vt is constant current by Rt, V1 is constant current by R1, and so on. And over here in parallel circuits, V is equal to It by Rt, because voltage is constant, and V, constant voltage, is I1 R1, and so on. Now you can combine circuits to form what is called a series parallel circuit, where you have this component and it is this single resistor is in series with two or more resistors in parallel. Now you have to consider, well, you have to think of the circuit too, is this portion is parallel, so the rules of the parallel circuit apply here. However, this parallel portion is in series with that. So when we're looking at the circuit as a whole, this is in series with that, but this by itself is parallel. And therefore by itself, when you're looking at this portion of the circuit by itself, it is governed by parallel rules. But when you're looking at the two together in a single circuit, the parallel portion is in series with the single resistor. One final point before I move on swiftly is that to tell if you have a parallel circuit, you look to see if current splits. In a series circuit, there is a single path, one single path for current to flow straight through these components like this. But in a parallel circuit, it could go here, then it could go here, and then it could go here. All of these are actual paths the current could take. So as long as current has more than one path, the circuit is parallel. If it is just one path, the circuit is series. Alright, now have I missed anything? I don't think I have. Moving swiftly along, we have to look at electricity in the home. Electricity in the home. And the first thing we have to look at, it is parallel, L-L-E-L, parallel over series, every day, all day. We choose parallel over series for two main reasons. The first is safety. Well, the first is practical, rather. You can't, or rather, if you have a series of devices in parallel, if you have a series of devices in series, that sounds crazy. You are going to basically overload that particular outlet circuit. You are going to, because the resistance, did I say resistance? But anyways, you're just going to overload that. It's like having what Guyanese call a power strip, and you plug everything in your house into it. The power strip is going to blow because you are drawing too much current from that one outlet. When you connect devices in parallel, there is safety because you have multiple paths through which current flows. If one of these paths goes bad, current is still going to flow through this one and that one. If you put all your devices in series, you only have one path. So if something goes wrong here, the path is broken, it is incomplete, and current does not flow. Parallel over series also brings us to the whole ammeter versus voltmeter discussion. The ammeter, A-M-M-E-T-E-R, which measures current, versus the voltmeter, which measures voltage. Now, the ammeter should have a low resistance. The voltmeter should have a high resistance. The ammeter should be connected in series. The voltmeter should be connected in parallel. Okay, just mentioning that here. Going back to electricity in the home, the next thing that must be looked at is, or examined, is safety. And safety brings us to three pieces of equipment that can be used. Electrical equipment then. It should really be called equipment. One is a connection, one is and the other two are devices. The first thing we have to look at is the earth or ground wire. Now the symbol for the earth or ground is this. And it literally is a connection from the internal wiring of the house to a metal rod, most likely copper, that has been buried in the earth. When I say buried, you could get a mallet and you could tap it into the ground if the ground is soft enough. Now what happens is this connection from the internal wiring of your house to the ground is of very low resistance. So anytime there's excess current, that excess current enters your home, whether through lightning strikes or good old GPL, you are going to have a very low resistance path for this excess current to flow through and not flow through the internal wiring of your house. The next thing is the fuse. Now the fuse is a metal element that melts when excess current flows through it, producing heat. That's all it is. You put it in the circuit, and when excess current flows around the circuit, it melts, opening the circuit. So the complete path for current to flow no longer exists, and you have no current flow. That's basically what the fuse is. Now fuses are rated at a particular current, and that current represents the current at which the fuse would melt. Next we have the how could I forget the name? Circuit breaker. CIRCUIT BREAKER. Now there is no diagram or anything you need to know for this. The circuit breaker is simply a device which automatically opens and turns off a circuit when excess current flows. That's all it does. You have a high current flowing and you don't, you have equipment that you don't want high current flowing through. You get yourself a circuit breaker or a circuit breaker panel, and most homes should, or businesses should, have one of these. And what happens is, the instant the current exceeds a certain value, the circuit breaker opens the circuit and current no longer flows. And that is electricity in the home. Now, the next thing we have to look at is, good old rectification, and the semiconductor diode and rectification. So, the semiconductor diode. This is the symbol. Now this is a device that only allows current to flow in one direction. Okay, that's it. It just allows current to flow in one direction. It is made up of what we call semiconductor materials. Now semiconductor materials are partial conductors. They have better conducting characteristics than insulators, but they are not as good as most common conductors or most metallic conductors. Now, since this device only allows current to flow in one direction, it proves useful in helping us convert AC to DC. Excuse me, sorry for that. Now this is our alternating wave. This portion of the wave is called the positive half cycle. And this is called a negative half cycle. CYCLE. What happens is current changes direction during this is one cycle or wavelength of alternating current. Up here it is traveling in one direction. Down here it is traveling in the opposite direction. So if we send or we pass this alternating signal through a semiconductor diode, right? Let's say this is the symbol we send through a semiconductor diode. What happens is, since the diode only conducts when current flows in one direction, part of this wave is going to be eliminated. You are going to you could get this part and you could lose that part. Now the half you use depends on how you connect the diode in the circuit. You could lose the top half, which is positive, or the bottom half, which is negative, all based on how you connect the diode. And this process, this is basically rectification. This is half wave rectification. Why half wave rectification? Because you get only half of the wave and you lose the other half. However, rectification as a process, right, can be rectification is a process. It can be defined as the process by which AC is converted to DC. A simple rectifier circuit would look like half-wave rectifier circuit would look like something like this. This is your alternating input. This is your semiconductor diode. This is a variable resistor. And this is your output. And this is a simple half-wave rectifier. All right. We have what? Logic gates and magnetism left to look at, and that will be the end of electricity and magnetism. Those videos will be uploaded shortly. Again, do share, like, subscribe, comment, and once again, thank you for your support. And I, as sleepy as I be, will see you in the next one. Take care.